All right, we are going to hit the ground running into Unit 4 today. We're starting with Lesson 1. So our lesson notes are pretty much the same as I talked about during the pre-assessment yesterday. Right here we have our exponential, we have our exponential growth and decay formula, A times B to the power of X. So just remember that A is your initial or your starting value. And I talked about this yesterday. B is your growth or decay factor. So if you are growing, then that means that your growth factor is greater than 1. If you're decaying, if you're going down, then your growth factor is less than 1. And I also talked about how to find the growth or decay factor if you are decreasing. So with that in mind, let's take a look at the examples. Okay. So a standard-sized piece of paper has an area of 93.5 square inches. If we keep folding the piece of paper into quarters, find the area of the paper after 3 rounds of folding. So, number 1, so we're going to, again, fill in our formula here. So A, again, is our initial value. So in this case, that's going to be the initial area of the piece of paper. So a standard-sized piece of paper has an area of 93.5. So A is going to be 93.5. Okay. B, if we keep folding the piece of paper into quarters. So the key word is quarters. We are folding the piece of paper into quarters. What do you think the decay factor is going to be? Obviously, everything is decreasing. If we're folding it into quarters, the size of the paper is going to decrease. So if we're folding it into quarters, that means my B value is going to be a quarter, or 0.25. 0.25 is 1/4. Okay. Find the area of the piece of paper after 3 rounds of folding. So our X value is going to be 3. So to find the X value, or to find the area after 3 rounds of folding, we need to calculate that. 93.5 times 0.25 to the power of 3. So let's go to Desmos again. So again, we want to do 93.5 times 0.25 to the power of 3. And we get that value. So our area is going to be, we'll say, approximately 1.46. So our area after 3 rounds of folding is 1.46. So that is the answer to number 1. Number 2, the value of an account in 1970 is $125. If the value grows exponentially at a rate of 5% per year, find the value of the account in 2020. Find the value of the account in 2020. So let's set this up again. We're using our exponential growth or decay formula. So A is our initial value. So what's our initial value of the account? That is $125. Okay. Our B value. Okay, the value grows exponentially at a rate of 5% per year. So 5% per year, it's growing. So that means our growth factor is going to be 1 plus 5%. 1 plus 5%. So 5% is 0.05. So 1 plus 0.05 is 1.05. So my B value is 1.05. Okay, find the value of the account in 2020. So 2020 is how many years later? Well, from 1970 to 2020 is, let's see, that would be what, 50 years? 1970 to 2000 is 30 years. 2000 to 2020 is 20 years. So, yes, that's 50 years. So, my exponent is going to be 50. So, to find the value of the account 50 years later, I need to calculate 125 times 1.05 to the power of 50. So, let's go ahead and do that. So, 125 times 1.05 to the power of 50, and we can find the value of the account. Okay, since we're talking about money, we're going to round to two decimal places, right? So that's going to be $1,433.42. So the value of the account, once again, is $1,433.42. So the value of the account in 2020 is that value right there. Okay. Number 3, the length of a photo is 150 millimeters. If we keep decreasing the size of the photo by 20%, find the length of the photo after 2 rounds of decreasing the size by 20%. Okay, so this is going to be an exponential decay problem. We're going to do it the same way, but this is exponential decay. So our initial value would be what? The initial length of the photo, so that's 150. Our B value we know has to be less than 1 because it's a decay. We're decreasing by 20%. So 20% is 0.20. So our decay factor is going to be 1 minus 0.20. 1 minus 0.20 is what? 0.80. So 1 minus 0.20 is 0.80. So my decay factor is going to be 0.80. And the question says, find the length of the photo after 2 rounds of decreasing the size by 20%. So my exponent is going to be 2. So I need to calculate 150 times 0.80 to the power of 2. 150 times 0.80 to the power of 2, and we get a value of 96. So the length would be 96 millimeters there. Okay, and that is it for Unit 4, Lesson 1.